Okay, this video is if you missed class, or if you want to do everything before class, here it is, right? Or maybe you're studying for the test because you're going to make the same graph on the test, right? The first thing I'm going to do is I'm going to make the line of best fit, and that seems to do it pretty well. Okay, and then I'm going to draw and notice that the line of best fit's going through a point there, and it's also going through a point there. Okay, and then I'm going to do my steepest and least steep lines. Draw those in. Voila, the steepest. Voila, the least steep. Now remember, we don't really use those lines to calculate their slopes. We can do that entirely from the data table, okay? But the best fit line, let's find that slope, okay? The best fit line, it looks to me, definitely the rise here is 3 volts, right? And it's really 3 electron volts, okay? So the rise is 3 volts, and then the run, well, what is this thing here? This is 1,000, this is 1,100, 1,200, 1,250 seems to be this edge here, okay? So this is just short of 1,250, so what is that? I'd say that that's 1,240. Minus, and then what is that? I think that's 520. Right? Okay. But remember that that's times 10 to the 12th hertz, right? Right? So that slope looks like this. 3 divided by, I'm just going to go 1,240 E12 minus 520 E12. And it's going to be a pretty small slope, right? I'm getting that it's 4.166 repeating e to the minus 15th. And the units are volts per hertz. Yeah? Really, it's electron volts, because remember, this axis here is stopping potential in volts, but the way that works out is that if you stop it with 2 volts, it's got 2 electron volts, right? Okay, but that's the first thing, right? So there's our best fit slope. Now I'm way too lazy to read these points off the graph, so to find my steepest line, I'm going to go from 0.2 to 2.9, right? So steepest is 2.9 minus 0.2. That's my rise. And my run is 1175 minus 620. Right? Okay, so I'm going to store that in B. Okay, and then I'm going 2.9 minus 0.2 divided by 1175, and these are both e to the 12, right? So 1175 E12, right? Minus 620 E12, right? And I get that that is 4.865 E minus 15. And I'm very heartened to see that that's bigger than my least steep one, right? Okay. And then the least steep one is going to go from 0.6 all the way up to 2.5. Right, and I'm getting that by saying that it's 2.7 minus 0.2, right? So least is 2.5 minus 0.6 divided by, here, let's draw a line of demarcation like that, right? Divided by 1175 minus 620. And these are, of course, E12, right? Okay. How lazy am I? Well, I'm so lazy that I'm going to go back and change that, right? So that guy is 2.5 minus 0.6, right? Is that right? Did I get that right? That doesn't sound right. That is right. Okay. The least steep is 3.423 e to the minus 15th, right? And this is, of course, volts per hertz. Volts per hertz, right? Okay. So find the slope, and then from the slope, calculate the value of Planck's constant in joule seconds. Well, let's see. This is volts, right? So to get from volts to joules, I believe we multiply by E, don't we? Okay. So the slope is, the best fit slope is 4.16 repeating, right? Okay. E to the minus 15. And then I'm going to multiply by, because this is electron volt seconds, right? Okay, because a hertz is a 1 over second, so really this is volt seconds, or electron volt seconds. This is really electron volt seconds, right? So I'm just going to multiply by 1.602 e minus 19, right? So, oh, I stored that thing, didn't I? Okay, so alpha b, there it is, divided, or times 1.602 e minus 19. With any luck, this will be Planck's constant. There it is, okay. So the best fit slope is 6.675 e minus 34, and that's now joule seconds, right? Okay. That's my best fit line, right? My my steepest line is 4.865 e minus 15, right? Times 1.602, because this is electron volt seconds, right? E minus 19 and so forth, right? Okay, so 4.865 e minus 15. Boy, there's some good glare there. There we go. Okay, times 1.602 e minus 19. So the biggest it could have been was 7.794, I'll say e minus 34 joule seconds, right? Biggest, right? And then the least one is going to be this value here, right? The least thing, the 3.423 e minus 15, and this is electron volt seconds, right? Times 1.602 e minus 19. Okay. Oops. So 3.423 e minus 15. Okay, times 1.602 e minus 19. And this is 5.484 e minus 34 joule seconds, right? So here are our values. This is what we think it is. This is the highest, that's the lowest, right? So what we got to do is we got to go high minus low divided by 2, okay? So high minus low over 2 is our uncertainty, right? Okay? So, parenthesis, 7.794 minus 5.484. I'm leaving off the 10 to the minus 34th because I think I can. Okay. 1.15. So I think what we're supposed to do is round that to one digit, right? So that is 7.794 minus 5.484 over 2. I'm getting 1.15. So I think what I do is I say that it's 1. Okay? So I think what IB wants us to do is round this thing to one place, right? So we would have to say, with the uncertainty of 1, we'd have to say this number here, right? This number here, we'd have to say it's 7 plus or minus 1. And I don't really like that. I like a 2-digit uncertainty. But I think, and then this is times 10 to the minus 34th joule seconds, right? But I think that's what IB wants us to do, right? I much prefer I like it this way better, 6.7 times 10 to the minus 34th, and then plus or minus 1.1 times 10 to the minus 34th, right? That's my favorite way to do it, but they want us to do one digit. That's what it would be with one digit. Okay, so find the minimum maximum slope. We've done that, right? Okay, express it. We've done that, right? And then number 4, we haven't done that. Use the extrapolation of the cutoff frequency to deduce the work function in electron volts. Well, that's actually pretty easy. Just look at that, right? What is that? I think that's 520 times 10 to the 12th hertz, right? Okay, so for the work function, remember the meaning of this is that photons at that energy just barely have enough energy to remove an electron. So the energy of that photon is the work function, right? So that's just going to be h f naught, where f naught is this thing, right? Yeah? And I think that that's 6.626 e minus 34 joule seconds times times 520. I thought that was 520, right? 520 e to the 12th hertz, right? So with the calculator, 6.626 e minus 34 times 520 e12, and I get 3.44552 e to the minus 19th joules, right? But it says get it in electron volts, so divide by 1.602, right? So divide by 1.602 e to the minus 19, and you get about 2.15 electron volts. Depends on how many sig figs you think you have, right? Okay. Okay. Now, that is your best guess, right? To get the upper and lower limit of this, right? To get the upper and lower limit, you actually do have to run these extrapolation lines down to the origin, right? Right. So now you're set. Can't you read these points here? Like that looks like 450. Yeah. Doesn't this one look like, let's see, it's that would be 575, so I think this is 585 maybe, right? Right? So what I think you're going to do is exactly what I did here. Here I used 520, right? Here I used 520 for that one, right? You're going to use 585 times 10 to the 12th for this upper limit, and then I think you're going to use 450 times 10 to the 12th for the lower one, right? And you're going to get a range of electron volts. Okay? So that is 6.626 e minus 34 times 585 e, not minus 12, times the 12th, right? And then that's, of course, divided by 1.602 e minus 19. So 2.41 is the upper limit. When I do it with this one, I get 2.41. I'll say 2.42, right? And then my lower limit is, how lazy am I? Well, I'm just going to change that 585 to 450. So my lower limit is like 1.86. Right? That's what I get. Whatever you get is what you get. Okay? You could use, by the way, point-point form to get the formula, and then, but, life's too short.